Okay, so if you look at this, we just have this matrix C, but what is C? C is the product of what? B and A, and we want to find the element C23. It means the element occupying the second row and third column in the matrix C. But first of all, let's check, does matrix C, does it make sense? How do you form matrix C? You multiply B. What is B? B, you can see it has 4 rows and 4 columns. And matrix A has 3 rows and what's 3 rows. Yeah, matrix A has 3 rows and 1, 2, and 4 columns. Let's see. Okay, matrix B. No, matrix B has 4 rows and 3 columns. This is matrix B. 4 rows. 1, 2, 3, 4. Column 1, column 1, column 2, column 3. Row 1, row 2 up to row 4. So now you see that this is going to make sense because this is 3 and this is also 3. So it will make sense. And it means matrix C will be a dimension of what? Of 4 by 4. So C equals to BA is possible. So this is since what? You see 3 is equals to 3, right? Since 3, it's equals to 3. And the dimension of C, it means the dimension of C is going to be what? 4 by 4. So this will be the dimension of C is 4. Dimension of C is going to be 4 by 4. Okay. So this is 4 by 4. Right. Now, but let's see, do we really need to have all the elements together? No, there's a shortcut on how to make this faster. So let's say you have B. This is B. B is what? B comes first. So let's write the whole of B, which is minus 1, 0, minus 2, minus 3, 4, minus 5, minus 6, 7, minus 8, minus 9, 10, minus 11. And where is A? A is this one. So this is matrix A, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, if you multiply this matrix, what are we supposed to get? We're supposed to get a 4 by 4 matrix. So it means you are going to get C11, C12, C13, C14, C21, C22, C23, C24, then C31, C32, C33, C4, 34. Remember, it's a 4 by 4. So the last one is going to be C41, C42, C43, C44. Right? This is going to be this matrix. Why? Because this, we saw it from here. This is 4 by 3. And this one is what? 3 by 4. We discussed this. But we are interested, and why do we use C? We are using C to represent the matrix, the element of matrix C. So if we need C23, it means you are only interested in this element here. We are only interested in this element, C23. This is C23. C23. So do we have to, are we interested in the other ones? No, we're not. So what is the fast way to get it? Just take, it means this element will come from the first row of what? The second row of the first matrix. So C23 is going to come from the second row of which matrix? This matrix. So it's going to come from here, this one, and which row? Which column? The third column. So where's the third column? This is the third column of the second matrix. So this is just what we need to do. We just need to multiply these terms. So what is this row? You can see this is -3, 4, -5. And then you multiply by this column, which is 2, 6, and what, 10. And here, this, you just need to multiply -3 times 2. So you have -3 times 2 plus this times this, which is 4 times 6 plus -5 times 10. And now you get, this is -6 plus 24. And this is minus what? -50, right? So this -6 plus 24, this is just going to be 18 minus 50, and this is -32. All right, now question number 2. For question number 2, it says what? You want to find the sum of all elements, of the sum of all elements of the what? The third column of matrix AB. So first of all, does AB make sense? Yes. So AB is going to be, why does it make sense? Because this is what? This is 2 by what? 2 by 3. And this one is 3 by 3. So you see that these three, they are the same. So it means we can multiply AB, which is simply -5, 4, 1, -5, 7, 2. Now multiply by B, this is -8, 6, -4, -1, 5, -3, -7, 5, and what? -1. Now, if we multiply this one, what is going to be the size of our new matrix? This is very important. If this is 3, 2 by 2, so it means the size of the new matrix is going to be 2 rows and what? 3 columns. So it means you are going to have something here. So let's call it anything you want. Let's call it D. D11, D22, D12, and what? D13. And here, or you can even call it AB. It's okay. If you like, you call it AB. So you can call it AB11, AB12, AB13. And here it's going to be AB21, AB22, and AB23. You can use any letter since it's just AB, right? Now, this is 2 by 3. So we are interested in what? In the sum of the element in the third column. So you go to the third column. Don't forget this is column 1, column 2, column what? 3. So it means you actually need what? We need AB13 plus what? AB23. Now, how do you get AB? How do you get AB13? AB13 will just come from the first row of the first matrix So which is going to be minus 5, 4, 1, multiply by the third row of the second matrix, the third column, which is minus 4, minus 3, minus 1. So this is what's I'm talking about here. So first row and what's third column. Now plus, because we're looking for the sum, plus AB23. AB23 means you take the second row of the first matrix, so which will be minus 7, minus 5, 7, 2, and then you multiply by what? 2, 3. So you go to also the third, right? The third column, which is going to be minus this. Right? So let's use this here. So this one is this one here, right? And the yellow remains as this and this remain all true. But this is also this. Okay, so just apply the multiplication. So now this is going to be minus 5 times what? Minus 4 plus 4 times minus 3 plus 1 times what? Minus 1. Then plus again. This and this will be minus 5 times minus 4 plus 7 times minus 3, then plus 2 times what? Minus 1. Now this will give us 20, and this is minus 12, and this is minus 1. Okay, then plus, this will be what? This is just going to be, let's finish this one together. This is just 20 minus what? 21 minus what? Minus 2. All right. So this is 20 minus 13. So from here, I think we have a 7 here. And this is 20 minus, this is minus 1, minus 3. So this is going to be plus minus 3. And this is going to be 7 minus 3, which is a 4. Okay. Very good. Now let's talk about something. The equality of matrix. Here we have to use the equality of matrix. So here we want to find what is x plus y. And this means that what? These matrices are what? The same. This is just telling you that these matrices are what? Are the same. So what will make the matrix the same? The matrix are the same first if they have the same dimension and the corresponding entries are the same. So if you look at this, both matrices have the same dimension, 3 by 3. So what it simply means is that we are supposed to, so we need to find what is x and what is y. So we can use any one. You can see it means that from here, these two corresponding elements are supposed to be the same. So we can say that x plus 2 has to be the same thing as 2x plus 6. And that means that what? It means that this is 0. This is 2x plus 6 minus x minus 2, right? So 0. So 0, it's equals to what? This is just x plus 4. Because 2x minus x, 6 minus this. So what is x? And the same way, we can find what is y. Now we have varieties. You can use either this or this. You can find, we can find y. But, let's see. Here, 2x, x, then. So x is equals to -4. Now, how can we find y? If you want to find y, you can use anyone. Where do we have y? We have y here. So we can use either this, we can use 2y here. So which is appearing here, and we have to use it here. They have to be the same. So take note of that. It has to be corresponding. So in other words, here, this is what we did. We used this one and this one. All right, so it means that we have 2y is equals to 18. So y is simply equals to 9. And this means that x plus y is going to be what? It's going to be -4 plus 9, which is 5. Now, let's go to number 4. So what is question number 4? Question number 4 is more of algebra as well. You have matrix A, B, C, and what? Yeah, A, B, C. So you just want to find a matrix D, which is AB minus C. So first of all, we need to find what is AB. Now, does AB make sense? Yes, because this is going to be, this is 2 by 3. And you want to multiply it with what? 3 by 2. Now, what is this one? This is going to be this times this. So what do we expect? It's always good to know what you expect. If this is what? So you are multiplying what? 2 by 3. You're multiplying it with 3 by what? 2. So you see that this the same. So we expect a 2 by 2 matrix. So the first one will come from where? This one. So what will be this row times what? This column. So you have 0 times 3, which is just 0, minus 2 times this. So you have minus 10. 7 times 6, right? And that should be 42, right? So you have plus 42. Then you go for the next one. 0 times 1 is what? Is 0. Minus 2 times this is going to be minus 10. Then 7 times 0. So this is plus 0. Now you go for the second row. You have 5 times 3. This is 15. 4 times this is minus 4. 3 times 6, this is plus what? 18. Then 5 times 1 is 5. 4 times 5 is 20. 3 times 0 is 0. So this will give us what? Minus 10 plus 42. I think this should give us 32. And this is just minus 10. And this is what? This is 11. So you have 29. And this is what? 25. Okay. So this is the element AB. Now, what is D? remember D is AB minus C. So we can also subtract because what we have now is a 2 by 2. Remember, you can only subtract matrices when they have the same what? The same dimension. So we have to remove C. And what is C? C is 40 minus 10, 28, 23, right? And subtraction is what? You do it entry-wise, right? So it's going to be 32 minus 40. This, I think, should be minus 8. But here you have minus 10 minus minus. So this is going to be 0. Then you have 29 minus 28. So here should be a 1. Then 25 to minus 23. This is going to be 2. All right. So we're asked to find the what? Then the, okay, I think this is something is missing. The sum of the element in the second, no, okay, no, no sum. It's asking for what? The element in the second row and what? Second column. So this is the element we are looking for. So where is the element in the second? Is this element. This is the second row, second column. And that element is 2. All right. All right, so let's look at the last question, question number 5, which is more of true or false. So here it says that what? If A, B, and C are n by n matrix. So n by n matrix, it means they are all square matrix. And In is the identity matrix of order n. So which of the following statement is what? Is true? Which one is true? So if you look here, let's see. This one is like this one. Is this true? This is saying if you have A plus B, if you remember this, we have this expansion in what? We have this expansion in pre-calculus 1, right? Pre-calculus 1. So here, is this statement true? Let's see. If you want to expand this, how do you expand this? You know, it's going to be this times this one. So this is going to be A cubed. Then you take A, you multiply this one. This is minus A square B. Then you take A again, you multiply B square. So this will be what? A B squared. Then when you finish, then you go with B now. So now you have B times A square. So this is going to be B A square. Then you take B and multiply this one. But remember, you are multiplying from the left. So the B will remain as what? B A B. Then you take B and multiply this one, the last one, which is B cubed. So here, okay, you know, the problem is that these guys, they are not the same. So you cannot cancel them because multiplication of matrix is not commutative. So it's not commutative. So you cannot cancel them. You have here, what do we have here? Let's look at this term. Will the term cancel? No, they will not cancel. Because here you have AB square. You have AB square. So this will not happen here. Okay. So let's look at this again. Let's look at this expansion again. Hope this is A times A square is A square B. A times this. So here is supposed to be yeah, this times this is this. This multiplied by this is this one, right? Then you have A, yes. Then now you have b times a squared, which is this. B multiplied by this. So this is supposed to be a minus here. Yes, so b multiplied by this one. Now, if you look here, look at this term here. This is a square b. And this is what? ba square. They cannot cancel. They are not the same because these are not real numbers. If it were real numbers, this one, I can write it as a square multiplied by b. Then this a squared b will just cancel this minus a squared b. But since this is matrix, it means that what? It means that we cannot what? We cannot cancel this one. So also look at this term, this one, and this one. They cannot cancel. So since they cannot cancel, you see, this is ab squared. But this one, we cannot change the position of b and a. So there will be no b squared. So it means that this is still what? Is still false. Nothing will cancel here. So this will be the 4. Okay? Because we are looking for what is true. Now, look at this one here. This is A. For B, what we have is A plus I, N, then A minus what? IN. I means what? The identity matrix. So let's multiply. So you have A times A, which will be A squared. Then you have A times minus I, which is going to be AIN, right? Then you have I times A, so you're going to be plus what? I times what? A, then minus what? IN squared. Okay, this is the good news. But the only matrix that commutes with what? That commutes with any matrix is the identity. So identity is just like 1. So in the real sense, here, there is no big deal. A times I is still just A. Plus I times A is still the same thing as A. Identity matrix is just like multiplying by 1. So then you have minus IN squared. So in this case, this A and minus A will go. So we will left with what? A squared minus IN squared. So this is true. So it means that number B is true. Now, C, is C true? No. This is A squared C. This is false. Now, is D true? No, D is not true. Because what do you have? You have A plus, no, A minus. You have A minus B all square. What does this mean? This simply means A minus B times what? A minus B. So now this is going to be A times A, which is A squared. A times minus B, you have minus AB. Then you have minus B times A, which is going to be minus BA. Then minus B times B is going to be plus what? B squared. So you see here, they are not the same. So you cannot say you have minus, right? So actually this is the correct one. A minus B squared is what? Is this one. So it means that this one is also what? It's also false. Okay. Then finally, we will look at what? We'll look at E. So for E, you have A plus I all square. Still the same. This is A plus what? I, A plus what? IN. So you expand, you will have a squared plus what? AIN plus INA plus what? IN what? Squared. Aha. Say now, what is this? If you look at this one, you cannot cancel anything, right? So this is just going to be remaining, but this is going to be a squared plus, but this is a times I. A times I is still going to be a plus I, and I times a is still a plus, so you will have a squared plus what? 2a plus what? IN squared. So this is what it is. So this is also false. All right, so that is the end for this video, series 411.2. Thank you for watching, and share with your friends, and also subscribe if you have not. Thank you for watching.